Good morning everyone. This is Triveni Engg Che, working as an assistant professor in the Department of Chemistry, Maharaja Institute of Technology, Mysuru. In this session, we discuss about construction and working of electrolyte concentration cell. Electrolyte concentration cell is an example for a galvanic cell. In this electrolyte concentration cell, both the electrodes and electrolyte present are made up of same metal and they are in contact with the same electrolyte. So that means electrolyte concentration cell is a galvanic cell in which electrode and electrolyte present in both the half cells are same, but the concentration of electrolyte is different. So then what is the driving force in this type of cell? The driving force in this type of cell is a difference in concentration of the electrolyte. So observe this diagram. This is the general representation of electrolyte concentration cell. The metal which is in contact with the solution of its metal ions, here the metal is considered as M. So it is in contact with the solution of its own ions, means it is Mn plus solution. Then in another compartment the metal is considered as M, then it is in contact with the metallic salt solution or its own solution Mn plus solution. Let us assume that the concentration of metal ions present at cathode is C2 molar and the concentration of metal ions present at anode compartment is C1. The metal which is in contact with a dilute solution develops a lower potential and that compartment acts as a anode, whereas the metal which is in contact with the concentrated solution develops higher potential and this compartment acts as a cathode. So for example, let us consider that this metal is a zinc metal. So what is the symbol for zinc? It is zinc. That means zinc is in contact with zinc ions. The concentration is, let us assume that the concentration is 0.1 molar. Similarly, in another half cell, zinc metal is in contact with the zinc sulfate solution. Its concentration is 0.5 molar. Observe that here the concentration of zinc is 0.1 molar. Here the concentration of zinc ion is 0.5 molar. The concentration at this half cell is lower. So therefore, this half cell acts as an anode. Here the concentration of zinc ion is more. So therefore, this half cell acts as a cathode. So when these two half cells are connected internally by a salt bridge and externally by a connecting wire. So observe that we are already familiar with the oxidation and reduction reaction. So at anode always oxidation reaction takes place. To represent the oxidation reaction at anode. So what is the cell reaction? It is oxidation. How to represent the general oxidation reaction? Metal M easily loses electrons, n number of electron, then we get Mn plus with the liberation of n electron. These metal ions are entering into the solution and the electrons are moving from anode to cathode. The difference in concentration, of the electrolyte make the redox reaction to happen. So therefore it drives the electrons from anode compartment to the cathode compartment through the external circuit. So at cathode what happens? The metal ions which are present in the solution migrate towards the vicinity of the electrode and they gain the electron, then it undergoes reduction. So therefore at cathode what happens? Reduction reaction takes place. How the general reduction reaction is represented? Mn plus gains n number of electrons, then it is reduced to metal. So observe that at anode oxidation reaction takes place. How the oxidation reaction is represented? General representation of oxidation reaction is metal easily loses n number of electron. So therefore this is the general representation of oxidation reaction. M gives Mn plus and n electrons. So how the general reduction reaction is represented? At cathode the metal ions gains the electron from the cathode and the metal ions are reduced to metal. So observe that here the metal ions present in the solution migrate towards the electrode and gains the electron from the anode and they get reduced. So, observe that then what is the net reaction or a overall reaction? So, net reaction or overall reaction in electrolyte concentration cell is nothing but it is simply the changes in concentration, that is Mn plus C2 concentration is changes to Mn plus C1 concentration. Observe that at anode, so according to the diagram the concentration of metal ion is considered as C1. So, therefore, this metal ion concentration is C1 and here at anode the concentration of metal ion is considered as C2. So, therefore, the net reaction or overall reaction is Mn plus C2 concentration is changes to Mn plus C1 concentration. This gives the information that during the reaction the concentration of metal ions at cathode gradually decreases, whereas at anode the concentration of metal ions gradually increases. Once both the half cells have reached the same concentration, the reaction stops. That means the cell stops developing potential. In this way, even though in this electrolyte concentration cell both the electrodes are same and the electrolyte is also same, but only the difference in concentration make the redox reaction to happen, thereby there will be a flow of electron from anode compartment to the cathode compartment through the external circuit. So, thereby it develops some potential in this type of electrolyte concentration cell. Then how to represent this electrolyte concentration cell? So, I already mentioned that it is an example for a galvanic cell. So, therefore, general representation of galvanic cell. So, that is first we have to represent the anode in the left hand side. How to represent the anode? First we have to write the metal. What is the metal taken according to the diagram? It is M. So, then single vertical line, then it is in contact with the metallic salt solution. Metallic salt solution is abbreviated as Mn plus. Then these two are in contact with, these two are internally connected by a salt bridge. So, therefore, two vertical line represent the salt bridge. Then how to represent the cathode? So, first we have to write the metal ion, then we have to write the metal. Here we have to mention the concentration of the metal ions in both the half cells. What is the concentration according to the diagram? It is C1 and this is C2. This is the general cell representation for a electrolyte concentration cell. Observe that this single vertical line represents the phase boundaries or phase changes. This is the solid and this is the liquid. Here this is the liquid and this is the solid. So, this is the general representation of electrolyte concentration cell. Then the cell reaction at anode, always oxidation reaction takes place. So, therefore, general representation of oxidation reaction, M gives Mn plus plus N electrons. At cathode, always reduction reaction takes place. General representation of reduction reaction is Mn plus N electron gives M. So, what is the net reaction or overall reaction in electrolyte concentration cell? It is simply the changes in concentration of metal ions at both the electrodes. So, during the cell reaction, the concentration at cathode gradually decreases and the concentration at anode gradually increases. After some time, both the half cells reach the same concentration. At that stage, the cell reaction stops. That means the cell stops developing potential. In this way, the electrolyte concentration cells work. Then how the EMF of electrolyte concentration cell is calculated? So, what is the general representation for EMF of a galvanic cell? It is E cell is equal to E naught cell plus 2.303 RT divided by NF log base 10 of concentration of metal ion at cathode divided by concentration of metal ion at anode. This is the general representation for EMF of a galvanic cell. For electrolyte concentration cell, E0 cell is 0. Why E0 cell is 0 for electrolyte concentration cell? Observe that here both the electrodes are made up of same metal, so therefore their electrode potential is same. So E0 cell expression expanded form is E0 cell is nothing but it is the standard electrode potential of cathode minus standard electrode potential of anode. So therefore for electrolyte concentration cell, E0 cell value is 0. So therefore what is the EMF of a concentration cell? It is E cell is equal to 2.303 RT divided by NF log base 10 of concentration of metal ion at cathode by concentration of metal ion at anode. So according to the diagram, what is the concentration of metal ion at cathode? It is C2 molar. And what is the concentration of metal ion at anode compartment? It is C1 molar. So therefore this expression becomes C2 by C1. This is the general equation to calculate the EMF of a concentration cell at any temperature. Then substitute the value of R, T and F. What is the R value? R value is 8.314 joule per Kelvin per mole, T is 298 Kelvin and F is a Faraday constant, its value is 96,500 joule per volt per mole. Substitute R, T and F and simplify that, we get the value as E cell is equal to 0.0591 divided by N log base 10 of C2 divided by C1. This is the general equation to calculate the EMF of a electrolyte concentration cell at 298 Kelvin. So this is the general equation to calculate the EMF of an electrolyte concentration cell at 298 Kelvin. Observe this equation when C2 is greater than C1. When C2 is greater than C1, E cell is always positive. That means there will be a spontaneous reaction. When C2 is greater than C1, E cell value is always positive and the cell reaction is spontaneous. For example, if C1 is greater than C2, C1 is greater than C2, in that case E cell value is negative and there is no spontaneous reaction. That means there will be a non-spontaneous reaction takes place. When C1 is equal to C2, concentration of C2 is equal to C1, then E cell value is 0. So E cell value is 0, that means the cell is at equilibrium. So that means there is no reaction. That means the cell stops developing potential at that stage. So when concentration of C1 is equal to C2. So this is the construction and working of electrolyte concentration cell. So let us discuss the problems on electrolyte concentration cell. So first problem, an electrolyte concentration cell consists of two magnesium electrodes dipped in magnesium nitrate solutions of 0.1 molar and 1.0 molar concentration at 298 degrees centigrade. Give the cell representation, cell reaction and calculate the EMF of the solution. Observe that here the temperature is 28 degrees centigrade, underline that it is, observe that 28 degrees centigrade, convert this to Kelvin scale, that means 273 plus 28, it is not equal to 298, so therefore underline this. So observe that, read the problem once again. So it is a electrolyte concentration cell, they are made up of two magnesium electrodes and they are in contact with the magnesium nitrate solution of concentration 0.1 molar and 1 molar at 28 degrees centigrade. So we have to represent the cell and we have to write the cell reaction, then we have to find out the EMF of the cell. So first we have to write the cell representation. Solution, how to represent the cell? So, both the electrodes are made up of magnesium. So, magnesium, then it is in contact with magnesium nitrate solution MgNO3 twice, because magnesium is bivalent and nitrate is a monovalent. So, therefore, magnesium nitrate formula is MgNO3. Then salt bridge is represented by two vertical lines. Then cathode representation MgNO3 twice, it is in contact with magnesium. So, then we have to mention the concentration of magnesium nitrate at anode compartment and the cathode compartment. What is the concentration? Always lower concentration should be represent for anode. So, therefore, it is 0.1 molar and higher concentration for cathode, that is 1.0 molar. This is the representation for this magnesium concentrated cell. Then we have to write the cell reaction. So, we have to write the anode, cathode and the net reaction. What is the anode reaction? So, anode oxidation reaction. So, what is the metal? Magnesium. Magnesium loses 2 electron, then it becomes Mg2 plus. So, we have to write the concentration of magnesium ions at anode, it is 0.1 molar. Next, cathode reaction, we have to write the reduction reaction. What is the reduction reaction for this metal? Mg2 plus gains 2 electrons from anode, then it is reduced to magnesium. What is the concentration of magnesium ions at cathode compartment? It is 1 molar. Then what is the net reaction? Net reaction is simply change in concentration, that is Mg2 plus gives Mg2 plus. That means 1 molar concentrated solution is diluted to 0.1 molar. So, these are the cell reaction for this problem, that is anode reaction, cathode and the net reaction. Then we have to calculate the EMF of the cell. So, what is the general formula to calculate the EMF of a electrolyte concentration? It is E cell is equal to 2.303 RT divided by NF log base 10 of C2 divided by C1. So, always C2 is greater than C1. Substitute the values, that is 2.303 RT divided, substitute the values. R value is 8.314 into T is, observe that 273 plus 28. So, 8 plus 3 is 11, 7 plus 2 is 9, 9 plus 1 is 10. So, that is 301. 301 divided by N is number of electron involved in the reaction is 2. So, then Faraday constant is 96,500. Simplify this, then we get 0.029 volt. This is the EMF for this cell. Next, move to the second problem. Read the problem. A concentration cell was constructed by 2 silver electrodes placed in 0.5 molar and 1 molar silver nitrate solutions. Write cell representation, cell reaction and calculate the EMF of the cell. First we have to represent the cell. Here both the electrodes are made up of silver metal. So, therefore, cell reaction, cell representation Ag, AgNO3, 2 vertical lines, AgNO3, single vertical line Ag. So, then we have to mention the concentration. So, concentration at anode is 0.5 molar, concentration at cathode is 1 molar. Then cell reaction, how to write the anode reaction? So, at anode oxidation takes place. Here it is a silver metal, observe that here the magnesium is a bivalent, remember that silver is a monovalent. So, therefore, it loses 1 electron. So, therefore, Ag plus electron. What is the concentration at anode? It is 0.5 molar. What is the cathode reaction? So, silver undergoes reduction, that is Ag plus gains electron, then it is reduced to Ag. What is the concentration? It is 1 molar. Then what is the net reaction? Net reaction. So Ag plus changes to Ag plus, that is 1 molar solution is changes to 0.5 molar. These are the cell representation. Then EMF for the concentration cell. What is the general representation to calculate the EMF of a cell? Observe that here they are not mentioning the temperature. So therefore write down the general representation for E cell of concentration cell, that is 0.0591 divided by n log base 10 of C2 divided by C1. Substitute the values. 0.0591. What is the n value? Number of electrons involved in the reaction is 1. So therefore n becomes 1. Then log base 10 of concentration of metal ion at anode is 1 molar and C1 is 0.5. So therefore simplify this. This becomes log 20. Log 20 value is 1.3010. So 0.0591 into 1.3010. Simplify this, we get 0.0798 volt. This is the first type problems in electrolyte concentration. Next problem. Represent the cell formed by the coupling of two copper electrodes in copper sulfate solutions. Concentration of cupric ions in one electrode system is 100 times more concentrated than the other. Write cell representation and calculate the potential at 300 Kelvin. Observe that here the temperature is other than 298. So therefore underline that. So therefore represent the cell formed by coupling of two copper electrode. That means this is the copper concentration cell. Concentration of cupric ions in one electrode system is 100 times more concentrated than the other. Write the cell reaction. Then how to write the cell reaction? So observe that it is an example for a copper concentration cell. So first write down the copper concentration cell. Copper in contact with copper sulfate solution. Copper sulfate solution in contact with copper. So observe that according to the given data, concentration of cupric ions in one electrode system is 100 times more concentrated. That means they are mentioning the concentration of metal ions at cathode. So let us assume that the concentration of metal ion at cathode compartment is 100 molar. Then what is the concentration of copper sulfate at anode? It is 100 times more concentrated. So therefore its concentration is 1 molar. Is it clear? Observe that according to the given data, the concentration of copper sulfate at one compartment is 100 times more concentrated than the other compartment. So therefore concentration of copper sulfate at anode compartment is 1 molar. Then we have to calculate the potential at 300 Kelvin. So therefore what is the general representation for electrolyte concentration cell? It is E cell is equal to 2.303 RT divided by NF log base 10 of C2 divided by C1. C2 is always greater than C1. So then substitute the values, that is 2.303, R value is 8.314 into, so this is 300 divided by N value is, it's a copper, so therefore N value is 2, F value is 96,500. So then log, so this is 100 divided by 1. So it becomes log 100 is nothing but 2, 2 get cancelled. So therefore answer is 0.0595 volt. Is it clear? Log 100 value is nothing but 2. So therefore this 2 and this 2 get cancelled. Then simplify this, then we get the value E cell value as 0.0595. Next problem, observe that EMF of the cell. So they are mentioning the cell representation. It is an example for a copper concentration cell at 300 Kelvin. So, copper which is in contact with 0.01 molar, but the concentration of copper sulphate at cathode is not mentioned. They are considered this one as a X molar. So, they are giving the EMF of the cell. EMF of the cell is 0.0591 volt. Find the concentration of copper sulphate at cathode. So, observe that here we have to find out the concentration of copper sulphate at cathode. That means we have to calculate the X value. Then how to solve this problem? First write down the EMF for this cell, that is E cell is equal to 2.303 RT divided by NF log base 10 of C2 divided by C1. Observe that they are mentioning the concentration of C1 and we have to find out the concentration of C2. So, first we have to simplify this. So, I am simplifying this equation like this: E cell into NF divided by 2.303 RT. Observe that I am cross multiplying these two. So, observe that E naught cell into NF divided by 2.303 equals log base 10 of C2. C2 value is X molar and C1 value is 0.01 molar. So, observe that. So, I am changing this log to left hand side, it becomes anti-log of this value. So, therefore, anti-log of this value, that is anti-log of E cell into NF divided by 2.303 RT equals X divided by 0.01. Next, I will substitute the value. So, that is anti-log of E cell value is 0.015, N value is 2, F value is 96,500 divided by 2.303, R value is 8.314 into 2 value is, T value is 300 into 0.01 is equal to X. Is it clear? I am taking this here, so therefore it becomes into 0.01. Next, simplify this and find out the anti-log for this. How to find the anti-log in calculator? First, press shift button, then press log, then enter this value. Then you will get the anti-log value for this values. Is it clear? So, therefore, find out the anti-log for this. We get 3.18 into 0.01 is equal to X. So, therefore, X is equal to 0.0318 molar. So, this is the concentration of copper sulphate at cathode compartment. Is it clear? So, observe that first we have to substitute the values for this, then find out the anti-log value for this, then multiply that with the concentration of the anode, then we get the concentration of cathode compartment. Its value is 0.0318. Observe that always cathode concentration should be greater than the anode concentration. So, therefore, its value is 0.03 is greater than 0.01.